right. Well, yeah, thanks, Richard, for that summary of how soil moisture is used in drought monitoring. Yeah, so I'm Brad Pugh, meteorologist at the Climate Prediction Center. One of my focuses is drought, both as a USDM author, but also drought outlook forecaster. So today I'm going to be presenting on how soil moisture informs the US drought outlooks. So give you a little peek behind the curtain on how we use soil moisture in our predictions. Next slide, please. So the monthly and seasonal drought outlooks use the US Drought Monitor as a starting point for forecasting persistence, improvement, or removal. And soil moisture initial conditions are very important in targeting areas for development, but large changes can certainly occur on a seasonal timescale. So soil moisture is a bit more relevant in a monthly drought outlook when initial conditions such as soil moisture and skillful temperature outlooks can best be used. And we will be at CPC implementing a flash drought risk soon to our week 2 hazards. Next slide, please. So as I mentioned, we do use the US Drought Monitor as a starting point. So for example, this was the US Drought Monitor from a couple of weeks ago. And on the right-hand side is our seasonal drought outlook showing the drought tendency during the outlook period, which runs through the end of June. Next slide, please. So how soil moisture used in prediction during the warm season, especially from May through August, anomalous soil moisture can influence surface temperatures, and it is utilized in CPC's week 3-4 monthly and seasonal temperature outlooks. So for example, when we have antecedent wetness, as we do now in the Ohio River Valley, that could provide a cooling effect on surface temperatures. Conversely, if we have antecedent dryness that we have over the southern high plains, that could provide a warming effect on surface temperatures. We also use a constructed analog method derived from soil moisture in our monthly and seasonal outlooks. Next slide, please. So here's an example of that constructed analog derived from soil moisture. So this is looking back historically at soil moisture conditions that match the current situation and projecting forward how that pattern will result in the temperatures on the monthlies and precipitation on the bottom there. Next slide. And here's the seasonal outlook for April, May, June, and this is using the soil moisture from March 24th. And I will say this actually matched the dynamical model output quite well from earlier this month, the temperatures. And in the past, during the warm season, we've had a fairly good skill using the constructed analog in terms of forecasting seasonal temperatures. Next slide, please. So next few slides, I'll be showing an example of how we used soil moisture in the monthly drought outlook. Next slide. So a couple of years ago, this was at the end of May, we had declining soil moisture across the central to southern plains. And using those initial conditions and the weekly temperature and precipitation forecast, we were showing a development in the monthly drought outlook across the southern plains. So by the end of June, we are forecasting developing drought across Oklahoma and the Texas Panhandle. Next slide. And this verified pretty well. If you look at a comparison of the Drought Monitor valid May 26th on top to June 9th on the bottom there, you can see the expansion of drought across the western and northern parts of Oklahoma, and also the intensifying drought across the Oklahoma Panhandle. So this is certainly a case of rapid onset and intensification of drought, and soil moisture played a large role in this in the forecast, and also what occurred there in Oklahoma. Next slide. And similar story across the Texas Panhandle. You can see the expansion of D1 short-term moderate drought from May 26th through June 9th, and also the intensifying drought across the northern Texas Panhandle. Next slide, please. So yeah, kind of using the methodology for the monthly drought outlook, which utilizes soil moisture. We wanted to apply that to our week 2 hazards product we have at CPC. We've had lots of feedback from stakeholders, and we thought this was something predictable that we should better communicate to the public on a week 2 time scale. So taking advantage of current initial conditions such as soil moisture, and also the skillful temperature forecast on the week 1 and week 2 time periods. We're using that to develop a week 2 flash drought hazard, and we're pretty close to implementing that. Hope to do that in May or June. And one of the reasons we're including this in our week 2 hazards is it's a major role in CPC's decision support services. We provide daily briefings, a briefing to NOAA headquarters, and also frequent emails to various regions when necessary. Next slide, please. So the inputs to this internal flash drought tool that we currently have going right now is initial conditions, abnormal dryness in the U.S. Drought Monitor, and soil moisture below the 30th percentile. And that's the CPC's leaky bucket modeled soil moisture. And then for our week 1 forecast, it would be the NDFD positive temperature anomalies and negative precipitation anomalies from the Weather Prediction Center during the next week. And on the week 2 time scale, the forecast input are the week 2 temperature and precipitation outlooks, elevated probabilities of above normal temperatures, and also below normal precipitation. So where all those conditions are met, that would spit out a flash drought signal for us to potentially forecast for. Next slide, please. And just for an example here, going back to February 23rd, the flash drought tool was highlighting an area across the Carolinas, parts of Florida, where there could be a rapid onset of drought, developing drought during the next 2 weeks. So by March 9th. Next slide, please. So checking out the U.S. Drought Monitor from February 22nd on the left-hand side, and on the right-hand side is March 8th. you can see the increase in D1 drought conditions across parts of the southeast, even D2 there in the nature coast of Florida. So, but pretty successful here, I thought, signal there in that flash drought tool. And once again, we're definitely using soil moisture as a part of the prediction. And next slide, please. So this is just a graphical format that what the week 2 hazards product would look like. So it'd be categorical in nature, just showing area most at risk of a flash drought by the end of the 2-week period. And we also forecast or try to forecast heat waves. So we have excessive heat. And of course, during the summer months, if you have antecedent dryness, heat waves and flash drought kind of go hand in hand, during June, July, and August especially. And next slide. And Highland showed this at a previous webinar, but I just wanted to remind everybody that there's some ongoing and future work with the help of NIDIS to develop atmospheric forcings to the NOAA soil moisture product from the early and mid 20th century, and also the kind of close that 4-day lag or latency of NLDAS forcings. And we do plan to prepare subseasonal and seasonal soil moisture forecasts using NOAA. And that would help contribute to the development of probabilistic subseasonal and seasonal drought outlooks at CPC. So that's certainly our goal, and it is in the works. And we would use bias-corrected and calibrated dynamical meteorological forecast of temperature and precipitation to help make those probabilistic drought outlooks more skillful. And I think that's all I have. Next slide, please. Yes. So yeah, thank you for your attention, and I think Laura is up next.